geobyte.
Another important problem. Look at this problem. Asking like this. A cylindrical metallic rod in thermal contact with two reservoirs of heat at its two ends conducts an amount of heat Q in time t. In time t, amount of heat conduction equal to Q. The metallic rod is melted and the material is formed into a rod of half of the radius of the original rod. If I assume R1 be the radius of original rod, then R2 equal to R1 by 2 according to given condition. Because the final radius of the rod is half of the original radius. What is the amount of heat conducted by the new rod when placed in thermal contact with the two reservoirs in time t? For the same time, right? What is the new rate of heat transfer? For that, as you know, right, the Q equal to K into A into T1 minus T2 divided by L into T. From this, no, for the same time period remains same, K remains same, T1 minus T2 also remaining same. From this, I can say that Q is proportional to A by L. But A equal to pi r square, A equal to pi r square. You can write either small r square or capital R square, right, by r square. Then Q is proportional to r square by L. Then I can say that Q equal to a constant into R square by L. L. Then Q1 by Q1 by Q2. Q1 by Q2 equal to K into R1 square by L1 divided by K into R2 square by L2. Here K will be cancelled. K will be cancelled. Then Q1 by Q2. Q1 by Q2 equal to R1 square by L1 by R2 square is what? R2 equal to R1 by 2. R1 by 2. So R1 by 2 whole square dividing by L2. Dividing by L2. Here volume V1 equal to V2. Volume remains same. Radius may be changing, but volume remains same. Right? So volume equal to what? V1 equal to pi R1 square L1 equal to pi R2 square L. Pi part is cancelled. R1 square L1 equal to R2 square. R1 by 2 whole square L2. Right, L2. Here R1 square L1 equal to R1 square by 4 L2. From this I can say that this R1 square is cancelled. This R1 square part is cancelled. L2 equal to 4 L1. L2 equal to 4 L1. Okay, 4 L1. So in the place of this L2, I can write 4 L1, 4 L1. Then this L1 cancelled. Finally 4 goes up. It is equal to 4 into R1 square by R1 square by 4. This R1 square is cancelled. 4 into 4, 4 into 4 is equal to 16. So you got, right, you got Q1 by Q2 equal to, I got Q1 by Q2 equal to 16. This Q1 is given, initial heat transfer rate is given Q by Q2 equal to 16. From this I can write that Q2 equal to Q by 16. Q by 16. Look at the option B. Option B is absolutely correct. Understood clearly? I try to explain the each and every point at your better understanding level. Understood or not? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. Asking like this. The total radiant energy per unit area normal to the direction of incidence received at a distance of Kepler from the center of a star of radius small r, whose outer surface radiates as a black body at a temperature T Kelvin is given by, you know, according to Stephen's law, according to Stephen's law, radiant energy emitted or rate of radiant energy emitted equal to A into sigma into T power 4. It is given that radius of the star is small r, therefore it is equal to 4 pi r square into sigma into T power 4. Okay, it is asking total radiant energy per unit area at a distance of capital R. Therefore, radiant energy per unit area at a distance of capital R equal to 4 pi r square into sigma into T power 4 divided by 4 pi capital R square. Here 4 pi cancel. Finally, it is r square sigma T power 4 by capital R square. That is the answer. Okay. Look at the option A. Option A is absolutely correct. Understood clearly? Simple problem. Okay. Similarly, let us take the another important problem. It is asking like this. The thermo EMF E in volt of a certain thermocouple is found to vary with the temperature difference theta in degrees centigrade between the two junctions according to the relation. Look at the relation which is given E equal to 30 theta minus theta square by 15. The neutral temperature for thermocouple will be. You are asked to decide neutral temperature for the thermocouple. Dear friends, remember at neutral temperature, remember dE by d theta equal to 0. Okay, let us simplify it. Simple mathematics. It is 30 minus 2 theta by 15 is equal to 0. From this, I can write that 2 theta by 15 is equal to 30, or 2 theta equal to 15 into 30. I can say 450. Theta equal to 450 divided by 2 equal to 225 degrees centigrade. That is the temperature difference at the neutral, right? That is the neutral temperature, right? Option A is absolutely correct. 225, na? Okay, sorry. Option C is absolutely correct. 225 degrees centigrade. Understood clearly? Yes. All the problems what we prepared completed. I hope all of you clearly understood. Understood or not? Yes. Thank you for watching. Okay? Yes.
Geobyte.